Hey, hello there. Welcome to the next video on functions module. In this video, we are going to discuss about the inline functions in C++. The inline functions basically help the programmer to make their program more efficient. Okay, so if you want to write more efficient program, then you can make use of, or you can think about using inline functions. Now always remember, the languages like C and C++ are basically invented for creating operating systems, or for creating low level system, or for creating efficient, highly efficient system. And that's why the function or the concept like inline function plays an important role. Okay, so inline function will help us, or it will help us to make our program more efficient. Okay, so we'll see how we can make our program more efficient by making use of inline function. So you can see on my screen we have a simple program where I have written a simple function, simple addition function. Okay, so you can see we have an add function. It is taking two arguments a and b, and then it is returning addition of a and b. Okay, now whenever I will have to use this function, I will call this function. So you can see on line number 11 I am calling this function. So what I am doing is I am taking one variable with name result, and I am assigning add, or whatever return value this add function is returning, I am assigning it to result variable. Okay, so this is very basic code. Now I am saying that this program is not efficient, or I am saying that we can even make this, or we can make this program even more efficient. Now you will say, what else we can do in it? Okay, because it is already like organized, we have already split it into the function and it looks good, so how we can even optimize it further? So the answer to this question is using inline functions. Okay, now inline function will help us to optimize our functions, or to help optimize the function overhead. Okay, now let's quickly go to a small presentation that I have created, and then let's try to understand kind of theoretically how the inline functions will help us. And let's first see what is an inline function. Okay, so let's quickly go to the presentation. So inline function, let's first see what is an inline function. So let me just tell you the definition of the inline function. So an inline function is a function that is expanded inline at a compile time. So as its name suggests, let's say we have a function, let's say add in our previous example. So if we make it inline, then that function will be expanded at the compile time. I'm going to tell you what do we mean by the function will be expanded at the compile time, so don't worry about that. But see how a basic execution of the function works. Okay, so we have a function, we call that function, then the control will be passed to that function, then that function will execute, and then that function will return us some value. So this is how the basic execution of the code works. But inline functions are treated specially. Okay, so what happens when we write any function, or when we make any function as inline? The function is expanded at the time of function call. Okay, and this happens at the compile time. So I'm going to show you in the program how this is going to happen, right? See, the compiler replaces the function call with the corresponding function code, and this basically helps to reduce the function calling overhead. Okay, so the compiler replaces the function body with function call. So whenever we have a function call, the compiler will replace that function call with the function body, and this will help us to reduce the function calling overhead. Now let's quickly understand what is overhead in the function call. Okay, let's first quickly understand what is overhead in the function call, why we don't want function call. Okay, see, the program, whenever we call a function, what is happening? The program need to hook to some random location. Okay, so let's say we have a program, right now we are in main function, and then we are apparently calling add function. So now what compiler need to do? Compiler will need to transfer the control to the add function. Okay, so it will need to hook to some random location in the memory where the function code starts, the function code of the new function, which is add, starts. So compiler needs to take control to that position. So this is a overhead, right? So to do this, what compiler needs to do? Compiler needs to store the current context of currently executing function onto the stack. See, whenever we call a function, how the compiler will know once the call of this function gets completed, from where or from which point in the current function it should resume the execution. Okay, let's say we have a main function, let's say we have 10 lines, let's say we are on line number 2. Okay, so in line number 2 we are calling another function, so then that function will get called, that function will execute. Now after the execution, how compiler will know that we should resume the execution of main function from which line? Okay, so it should need to store it somewhere, so compiler will store this information onto the stack memories. This is kind of a overhead that the compiler will need to do when we will execute a function or when we will call a function. The another thing is that whenever we call a function, we pass some arguments to the function. Okay, so usually you can see in add function that we have written earlier, we are passing two arguments, a and b. So these arguments needs to be copied to the function stack, or it needs to be copied on the stack frame of the function that we are calling. Again, this is the overhead, right? And the third thing is, whenever we execute our program, for the optimization, for the CPU optimization, there is a mechanism called as cache mechanism. Okay, so if you're using a machine where this cache mechanism fetches instruction from the memory in parallel, then again it's gonna be overhead for your system. Okay, because you are transferring your control to the next location or another memory location, and then the cache will again have to cache the instruction from there, so it's again going to be overhead. So these are some overheads of the function call, and for avoiding these overheads we have inline function. So let's quickly see why inline. Okay, to avoid this overhead we are inlining the function. So let's see some concrete reason behind inlining a function. See, for the function that are large in size, let's say a function which is having 200 line of code, for such function the overhead that we have seen on previous slide doesn't really matter. Okay, so let's say we have a function with 200 lines, then for transferring control to that function, then copying arguments of that function on its stack frame, that time will be considerable. I mean, the execution of the execution time of the function is going to be much higher than the time that we require to do all this pre-processing stuff or all these things. Okay, so you can see what I have written is, for the function that are large and perform complex tasks, the overhead of function call is usually insignificant compared to the amount of time function takes to run. Okay, but for small functions, when we have small functions like commonly used function like add function, the time needed to make the function call is often lot more than the time required to execute the function. This is something which happens. So if we have a very small function, then the time required to call the function is more than the time required to execute the function, and this is an issue. Okay, let's say we have to execute one single line of code, and for execution of that one single line of code we have to make all this stuff. Okay, we have to save the current execution context on the stack, then we have to copy paste the arguments, and a whole lot of things. So to handle this thing, to deal with this thing, we have inline functions. Okay, so let's quickly go to the Visual Studio Code. Let's see how we can make our function inline and how it can help us. Okay, so let's quickly go to the Visual Studio Code. Okay, so we have add function. It's really small function. Okay, it's single line function. Okay, so as we have discussed, for small function the function call overhead is going to be much larger than the execution or the time required to execute the function, and that's the reason what we are going to do now. We are going to inline this function. Now what will happen if we will inline this function? If we will inline this function, what compiler is going to do? Compiler will replace the function call with function body. Okay, now what is the function body? Here in add function, what is the function body? It is saying return a plus b. So basically we can replace add 10 comma 20 with, we can replace it with a plus b. And what is going to be value of a in this case? When we are passing 10 and 20 as the input, the value of a is going to be 10 and value of b is going to be 20. So basically we can replace function call of add 10 comma 20 with 10 plus 20. Now this is something which compiler will do for us. We don't have to do it ourselves. The compiler will do it for us. We just need to instruct the compiler that we want add function to be inline, or we want the function call of add function to be replaced with function body, and that's why for such functions you need to declare them as inline. How we can declare a function as inline? It's very easy. You just have to append, or you just have to add inline keyword before the function. So in function declaration or in function definition, whenever you define a function, what you have to do is you just have to add inline keyword before the declaration of the function, or before I will say return type of the function. Whenever you will add inline keyword before the function, the compiler will know that this function is going to be inline. So the compiler will understand that it will have to replace the function call with function body. Okay, so in this way we can make a function as inline function. See, creating inline function is very easy. From the placement perspective, what we need to understand is why we are creating a function as inline function. So maybe in your interviews, maybe the interviewer can ask you this thing: do you know inline function? Then you may answer, yes, I know inline function. Then he may ask, what is an inline function? Okay, or he may ask why we make function as inline. So in that case, you should explain him all the stuff that we discussed in this video. So you should explain him how the function call is overhead. Okay, what all things happen when we call a function, and how the function call is not really affordable when our function body is very small. Okay, so always remember, we usually write inline function when the function is usually small. Okay, when the function is like of size 2-3 lines, so in that case we make our function as inline. Okay, and another important thing about the inline function is inline is not a command to the compiler. Okay, it's not the order to the compiler, it's just a request. It's just a request to the compiler that please check if you can make this function as inline. If the compiler feels that this function is suitable for inlining, then and then only compiler will make it inline. Otherwise the compiler will reject your request and compiler will execute the function as the normally, or in the way the normally function executes. Okay, so always remember, inlining is just a request to the compiler, it's not a command. Okay, so don't think that if you make a function inline, or if you define a function as inline, then always the function call is going to be replaced with the function body. It's not going to happen. The compiler is the entity which is going to decide whether or not this function can be made as inline. Alright, so there are few rules where you cannot make the function as inline. So let's quickly see what are the rules where you cannot make your function as inline. Alright, so let me quickly show you some rules where you cannot make your function as inline. So the first rule is, if your function contains loops like for loop, while loop, do while loop, so in that case the compiler cannot make your function as inline. Okay, because looping is kind of a complex syntax. Okay, so in that case it's not really makes sense to replace your function call with function body. Okay, then the next thing is that whenever your function contains static variable, in that case as well your compiler cannot make it inline. Now we actually don't have any idea about static variables, so we are going to discuss about the static variable in the module with name scoping and lifespan of a variable in C++. So in that module you will understand what is an static variable. So right now just don't worry about that. Right now just remember, whenever your function contains a static variable, in that case compiler cannot make your function as inline. Okay, then the next thing is that if your function is recursive, then also compiler cannot make it inline. Then if your function's return type is other than void, and if the return statement doesn't exist in function body. Okay, so if your function's return type is, let's say, int, and if there is no return statement in the function body, then also your compiler cannot make it inline. And the final point is, if the function contains a switch statement, then also the compiler cannot make it inline. Okay, so I hope you will remember these points. If there are loops, then we cannot inline it. If the function is recursive, then we cannot inline it. If the function contains some static variable, then also we cannot inline it. If the function contains switch statement, then also we cannot inline it. All right. So this was about the inline function. So I hope you have got an idea why we choose inline function, what is benefit of having an inline function. So as it has some benefits, it also has some disadvantages. So let's quickly understand what are the advantages and disadvantages of having an inline function. So let's first discuss about the advantages. So the first advantage is it does not require function calling overhead. So whenever we declare a function as inline, it does not require function calling overhead. It is very important advantage of inline function. Then it also saves overhead of variable push and pop on the stack. So actually this also gets covered in the function calling overhead, right? And there is also overhead when we return something from the function. So it also saves the overhead when we return something from the function. Okay, let's discuss about the disadvantages of the inline function now. Now the very first disadvantage of the inline function is if too many inline functions, or if you use too many inline functions, then the size of code, your code size is going to increase. Now why it is going to increase? See, what is basic idea behind writing a function? We write a function for reusability. We write a function so that we can reuse the same code. Okay, by reusing the same code, our function or our program size remains a little bit smaller, because we are using same code chunk again and again whenever we require that logic. All right. But in case of inline function, what is happening? We are copy pasting same code chunk wherever we are calling that function. At whatever places you are calling that function, you are going to replace the body of that function with the function call, and that's the reason there is a chance, if you have so many inline functions in your code, then there is a chance that your code size will going to be increased. Okay. The next point about the inline function is due to increase in function size, it may not be fit for cache mechanism. Okay, so if your function is too big, so let's say in main you are calling inline function 10 times, so the size of your main function will increase, right? It will be big then. Okay, so due to its big size, it may not be qualified for the cache mechanism. Okay, and the next and most important point is in embedded system, okay, where the size of the program matters a lot, their inlining cannot be that much helpful, because their code size is more important as compared to the speed. Okay, so whenever you use inline function, it should be a thoughtful decision based on where the program is going to execute, and on which machine, or what is going to be the execution environment. So you should think of all these scenarios, and based on that you should take the decision whether or not to make your function inline. Okay, as a regular programmer, we actually don't care much about making a function inline. So if you are coding something like operating system, or if you are making some system software, then in that case you should always care about whether or not to make a function as inline. So I hope you enjoyed watching this video. I hope you got all the concepts that we covered in this video.